Assalamu alaikum students. I am going to give a lecture about chapter number 3rd. Name is gases, and we will study topic gas laws. First of all, you should know what is definition of gas laws. Definition is that the relationship between volume, temperature, and pressure of a given mass of a gas is called gas laws. There are various gas laws: Boyle's law, Charles' law, Avogadro's law. First of all, we will study Boyle's law and statement. The volume of a given mass of gas at constant temperature is inversely proportional to the pressure applied to the gas. And it is mathematical representation: volume inversely proportional to pressure in Boyle's law, and volume is equal to, when sign of proportionality is finished, then constant is taken. V is equal to K over P, K constant, PV, and P cross multiplication here, PV is equal to K. T and N, temperature and number of moles, are being held constant. Boyle's law can also be defined as, from this equation, product of pressure and volume is always constant at constant temperature. Applying initial and final conditions on this equation, P1 V1 is equal to P2 V2. Now we will discuss experimental verification. We will explain Boyle's law with the help of an experiment. For this experiment, 3 cylinders of gases are taken. In first cylinder, the pressure is 2 atmosphere, volume 1 decimeter cube. In second cylinder, pressure is doubled, volume remains half. And third cylinder, pressure is 3 times, volume is reduced to 3 times. Here, this variation shows that when pressure is increased, volume decreases. This is inverse proportional, and this is experimental verification of Boyle's law. And this is mathematical representation of Boyle's law, that P1 V1, when these values are put from the experiment. In the first cylinder, 2 atmosphere pressure, volume is this, and answer is 2 decimeter cube atmosphere. And P2 V2, in the second cylinder, pressure is 2 times double, then the volume is half, and answer is also 2. P3 V3, when we put the values of third cylinder, then answer is same in 3 cases. 2 2 2 means P1 V1 is equal to P2 V2 is equal to P3 V3. This is the mathematical representation of Boyle's law. And this is graphical representation of Boyle's law. When we plot values of volume versus pressure, inverse relationship. This graph shows inverse relationship. Parabolic curve is obtained. And since this experiment takes place at the constant temperature, so this curve obtained is called isotherm, and it is taken at 0 degree centigrade. Next graph, temperature, the plot is graph is plotted between values of pressure and volume at 2 different temperatures. Temperature is 0 degree centigrade, this curve is obtained. Temperature 25 degree centigrade. Difference is that at higher temperature, when temperature is increased, then the curve is obtained. Curve obtained is far away from the 2 axes. And third is plot of values between pressure and 1 over V. This is direct relationship, P and V. When direct relationship, then the graph is obtained is straight line graph obtained. This straight line shows that direct relationship between P and V. This is another representation of Boyle's law. Then we will move towards Charles' law. Charles' law statement: the volume of a given mass of a gas is directly proportional to the temperature at constant pressure. V directly proportional to T. V is equal to KT. V over T is equal to K constant. Applying initial and final conditions, V1 T1 is equal to V2 over T2. We will use these formulas in the numericals. Numericals will be solved by using this formula. All the 3 values are given, and only one will have to find. So this formula will be used for the further numerical problem solving. And scales of thermometry. There are three scales of thermometry, as you know well: the centigrade scale, Fahrenheit scale, and absolute or Kelvin scale. And in these scales, students, you have to remember these three points in all three scales. First point for centigrade scale, freezing point on this scale is 0 degree centigrade. Boiling point of water on this scale is 100 degree centigrade, and the space between these two temperatures is divided into 100 equal parts. And in Fahrenheit scale, melting point of ice is 32 degree Fahrenheit. Boiling point of water is 212 degree Fahrenheit. 180 equal parts divided between these 2 points. And absolute Kelvin scale, the melting point of ice is 273 Kelvin. The boiling point of water is 373 Kelvin. 100 equal parts between these 2 points are taken. Now next we will discuss interconversion formulas. If temperature in centigrade scale, how can we convert into Fahrenheit or Kelvin scale? And for these conversions, the following formula are suggested. For example, look at this K is equal to C plus 273. If temperature is given in numerical centigrade, then we can convert this temperature into Kelvin scale by using this formula. Then C is equal to 5 over 9 F minus 32. If temperature is given in Fahrenheit, then we will convert into centigrade, and Fahrenheit is equal to 9 over 5 C plus 32. If temperature is given in centigrade, then we can convert it into Fahrenheit by using this formula. Now we will move to our next topic, general gas equation. General gas equation. We will drive this equation by using all the above three laws: Boyle's law, Charles and Avogadro's law. And according to Boyle's law, V inversely proportional to pressure when temperature is constant. And according to Charles' law, this is statement of Charles' law: volume directly proportional to temperature at constant pressure. According to Avogadro's law, volume directly proportional to number of moles at constant temperature and pressure. By combining all of the above relationships, we can get V directly proportional to Nt over P, because N and T are directly proportional and P inversely. So we will write here V is equal to constant Nt over P, and constant R is called general gas constant. Here we can write here capital R, general gas constant. V is equal to R Nt over P, and P will move here. PV is equal to nRT. This is general expression of ideal gas equation, general gas equation. And this equation can also be reduced to their respective laws by considering variables which are being held constant. And look here, PV is equal to nRT. When T and N are held constant, PV is equal to K. This statement will reduce to nRT a constant, N and T are constant, and R is also constant, so we can replace these three constants by single constant K. PV is equal to K. You have learned before that PV is equal to K is a statement of Boyle's law. Similarly, we can derive or we can reduce this expression to Charles' law. V is equal to R Nt over P. We will arrange this equation because we will have to derive Charles' law from here. Here P and N are constant. P and N are taken constants, and R is also constant. V is equal to Kt, and V is equal to Kt is Charles' law statement. And then V is equal to R Nt over P when P and T are held constant. If we take P and T constant and R also constant, V is equal to Kt, Kn. N means, and this is Avogadro's law. So we can reduce the above formula by using constants in the respective laws, and we can deduce the respective laws from the ideal gas equation. And if we take 1 mole of a gas, then PV is equal to, here N is equal to 1. So we can write this equation: PV is equal to RT, and PV over T is equal to R. applying initial and final conditions, P1 V1 over T1 is equal to P2 V2 over T2. Okay students, this is our today's topic, and inshallah next we will study further of the topics of this chapter. Okay, thank you. Allah Hafiz.